Kubernetes brings in a lot of complexities, and people have this tendency to think that I'll just move to Kubernetes and that will solve all of my scaling issues, will solve all of my performance issues, will reduce my cost. It's not the way it works. I mean, it has its upsides and downsides.
This is DevOps Paradox, episode number 196, Simplifying Performance Optimization Using Granulate. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. As we begin out 2023, or now we're into 2023, our budgets are now locked in. But typically budgets mean money. But budgets mean a lot more than that. They also mean performance. What do you think about that, Victor?
They're related to each other, right? Performance. Of course, you can increase performance by saying, hey, I'm going to have 100 gigabytes of RAM for my tiny application, and it will always be performant, right? Which is not true to begin with. But if you assume that by performance we mean it is running as optimum as it can be, then that's tightly related to budgets, to money, right? Because if you run just the right number of replicas on just the right hardware, and those applications are provisioned to use just the right amount of CPU and memory, then I would say that those two things are very much related.
So why are we talking about performance? Much like anything else, it comes down to, are we making our customers happy at a cost-efficient manner to where we're either breaking even or preferably making a profit? So we have Noam Salinger on today from Granulate. Noam, how you doing?
Hey guys, it's great to be on your show.
With Granulate, you've got lots of different offerings, and at the end we'll talk more about Granulate in specific. But when people start out, again, budgets, the hard cash budgets obviously help determine some performance, but usually as software developers and SREs, we're not thinking about that dollar cost day one. Sometimes we do, sometimes we don't. We're just trying to get our apps running. And the number one thing that typically happens is, okay, it looks like we're CPU bound, looks like we're memory bound, throw more hardware at it, right? Everybody goes through that cycle. But at some point, you just don't need that much power anymore. I mean, in today's world, in 2023, what are different ways that we can see and manage that performance overrun, if you will, because we've provisioned way too much hardware?
So our approach to it is that you don't need to compromise. I mean, there's always that trade-off between finding that high quality of service with high utilization. And you always try to play around with monitoring, provisioning, placement. And the way we look at it is you don't need to compromise to one or the other. What we try to help our customers achieve is try to get that sweet spot with a lot of heavy lifting. So basically have high utilization and low cost, and not have to do a lot of hard work and going back to monitoring and changing it periodically. Let us do the heavy lifting. So we do believe that that's a state that could be achieved. Our vision is to try to get to the self-managing workloads in a way. So where you define the logic and you do not need to work a lot and getting to that sweet spot. So I'm a big believer of that. That basically what drives us to get up in the morning and try to help our customer to get to that euphoric state.
When you say high utilization, do you mean happy utilization? Meaning it's not too hot and not too cold, or what is the right utilization?
So that's a great question. I think it really depends on the specific use case and the specific application. I mean, each one has his sweet spot. I mean, not every application behaves the same. I mean, you can have a Kubernetes application where you would be running it at 80% CPU utilization, which is, not that orthodox. And you can have an application running at 30% CPU utilization, you'd be still happy. So I think it really depends on the specific use case, the specific application, the type of traffic that you see incoming. And I mean, no one wants to give up availability. I mean, availability is a given and performance is a given, in my opinion. So I think it depends like where you want to position that sweet spot and how you want to get there.
How do we know how to tune for that sweet spot? Like if I'm thinking in-memory cache, I'm going to want lots of memory and I can probably get by with less CPU. I mean, this gets into just thinking any of the cloud vendors, right? There's usually memory optimized, CPU optimized, general workload optimized. What is a good strategy for people when they're first getting their app rolling out, or even if it's brownfield, it's been out there for a long time and it's okay, where should they first start looking to try to figure out, okay, what is the right way to optimize for this to where eventually I can start saving some cash on the back end?
I would say that something that's a bit surprising is that we come across a lot of companies that are quite mature. I mean, not early stage startups. I'm talking about big enterprise, which haven't implemented the very basic go-to best practices. I mean, starting from finding the right instance type to shutting off idle machines to, monitoring and seeing the actual utilization and tuning it periodically. I would say just a rule of thumb, start from there. I mean, don't start from doing complex stuff and trying to do, I mean, there are other options. I think it's a journey. It's not something you do once and you're done. But I think many cases people overlook those simple solutions, such as just shutting off idle machines, finding the right instance type, looking whether you're CPU or memory bound, and finding the right mix of infrastructure that's tailored to all your needs. I would say that's the best way to begin, in my opinion.
Let's assume for a moment people did that right thing. Once they have that information and they've assumed they've gotten all the right instance sizes and whatever else goes along with that. Again, thinking in 2023, 10 years ago, we couldn't have done a lot of cool things that we can do now. I mean, what are some of the trends that you're seeing? One big buzzword is always eBPF, right? Even though it's been around for quite a while. What are those other types of trends that I've gone past the basics and let's ignore the magic AI is running everything? Where's the reality in the middle there?
So I think we see more and more companies going towards managed solutions instead of manually configuring and setting up their environment. I think we see a lot of that. And we see AWS, bringing, not only AWS, I think most of the cloud providers are nowadays bringing more managed solutions. So I think Kubernetes brought in a lot of complexity into the game, and properly tuning it makes it's an ongoing struggle, a never-ending struggle in my opinion. So I think going towards those managed solutions and bringing in external vendors that can help you with specific problems. I mean, Granulate is just one of them, but I think today there are many, many different vendors that offer those managed solutions that help you sort of take off some of that stress and some of that heavy lifting you need to do to get to that ideal state. So yeah, I think eBPF, you mentioned it before, I think that's a game changer in many different fields. We use that as part of our profiler, for example, and it enables us to do stuff that was not available, I think, 1 or 2 years ago. For example, running cluster-wide profiling on your entire cluster all the time. I mean, that's something that was not possible a year or two ago before eBPF. So I think, there are a few new cool technologies that have changed the game.
But the real challenge there is how to, figuring out how much memory CPU your application needs or your service should be. To me, that sounds relatively easy if your goal is to figure it out for right now. The problem is the situation is changing all the time, right? It's not anymore that much about figuring out the typical question from early days of my career, how much memory and CPU your application needs. And that varies, right? That changes differently. And then you mentioned Kubernetes, right? And what strikes me as curious or not so nice, let's say, is that we have the tools, but we cannot combine them. We have horizontal pod autoscaler or variations of it that will scale my application horizontally. We have vertical pod autoscaler that will increase or decrease amount of resources my application needs, but I cannot use both of them together. I dare anybody to try to use both of them together and tell me the results.
That's impossible. I just want to say I can totally relate to a bunch of stuff you just said. I mean, from finding the right amount, specifically in Kubernetes, so allocating the right amount of resources such as memory, CPU, setting the HPA properly, using VPA in many cases. So doing that in a place where you multi-cluster, scaling up, dynamic traffic, dynamic environment. I mean, it's a hard task. I mean, it's something that we've came across from day one with Granulate. So many Kubernetes customers say exactly that. I mean, just now when we visited KubeCon, we had a question. So how do you determine the right resource request for your deployment? So we asked like a lot of people, and the answers were very funny. Some of them just said we guess a random number. Some of them said we remove the HPA, we add VPA, then we finish it up and put the HPA back again. Some of them just use heuristics. Some of them say, oh, it was hard. I mean, people give just funny answers into how they said it properly. This is the exact reason why we decided to address that specific problem. And that's why we've developed a product called gMaestro, which does exactly that. I mean, not only finding the right amount of resources, but actually doing it over time and doing it in dynamic environments. gMaestro does exactly that. It's a tool that is used on Kubernetes environments, basically learn the specific resource, how much is reserved and how much is actually utilized in real time. And not only provides recommendations, but actually does the changes in real time to take off that heavy lifting of trying to guess, use HPA, use VPA. I mean, it works together with hand in hand with HPA and provide a solution that doesn't require any heavy lifting, any periodic coming back to it, no monitoring, no more. So that's exactly what we are trying to do. We're very excited about that product. We just recently launched it just a few months back. Very, very excited about it.
Throughout all your work, what have you seen being some of the most common struggles when people first start out with Kubernetes? Or even if it's not just starting out, but along their path?
We discussed one of the main issues the way we see it. I mean, I'm a bit biased because it's something we decided to actively try and help out with. But I think even simple stuff such as properly setting the environment, how do you slice and dice it properly into the different entities in Kubernetes, whether you run a single container in a single deployment, how do you use namespaces properly? I think some people are missing the core basics into setting up a proper Kubernetes environment. And the problem is that there's this gold rush. I mean, everyone's talking about Kubernetes, so everyone wants to be there, so everyone's using Kubernetes, even if they're missing the core information into how to properly set it up, and then trying to fix it once you're already starting to scale up is a big problem. I mean, that's something that we see a lot where we have basically a monolith running over Kubernetes, and trying to fix it is quite hard now where you already rolled out through multiple regions and high scale. I would say that's also something that we come across a lot.
What do you think about solutions like GK Autopilot that essentially give you a cluster where each pod is running in a separate node as a way to scale up and scale down?
I think it's a bit missing the point in my opinion, because if you're basically running a single pod on a single node, you're not properly using the dynamic and the advantages of using Kubernetes that is sort of an ephemeral cluster that spins up and down based on usage, based on the actual state of the cluster. So in general, it's my opinion. I mean, I'm quite sure there are a few people in the audience who are hearing this and they have a lot to say about it. But I think in general, the dynamic approach to Kubernetes is not something that I am a big fan of.
I tend to agree. I'm not extremely happy with one pod per node. But we have that problem that eventually your cluster needs to scale up and scale down the nodes, right? And then that can be really, at least from cost perspective, really issue because, hey, if I cannot schedule this pod, I need a new node, and that node happens to be 10 times bigger than the size of the node. So I almost feel that we're in a deadlock between inefficiency of tiny nodes that are just for the size of a pod and scaling by increasing the number of nodes simply, right? One gives you potential issues with scaling too often, another gives you too much wasted resources. which wasted resources do not affect performance, but still do affect the cost of it, right?
Yeah, definitely. I mean, it brings in a lot of complexities. We're just using VMs where you have just one dimension you need to properly tune. Now in Kubernetes, you have the node pools, which you need to get the right amount, the right instances, setting up the actual infrastructure. Then you have the HPA resource requests, setting that correctly. And also it does the bin packing, which you just mentioned, which is also a big issue. So how do you pack the pods on the nodes in a way that's efficient? It doesn't really leave a lot of excess waste per each one of the different nodes. So I agree. Kubernetes brings in a lot of complexities, and people have this tendency to think that I'll just move to Kubernetes and that will solve all of my scaling issues, will solve all of my performance issues, will reduce my cost. It's not no way it works. I mean, it has its upsides and its downsides. When it's properly tuned, you can have this machine that doesn't require any attention, it's properly scales up, scales down, hits that sweet spot we started the podcast with. I mean, you can reach that place, but it does require some setting up. It does require routine maintenance. It does require some expertise and knowledge into how to properly tune Kubernetes. I mean, it's not an easy task. I mean, that's the reason that we believe that any way that we can help out, I mean, the approach we took is let's try to automate some of the parts that are hard for those people. Let's find those places where it's mistreated. It's not, people don't give the right amount of attention, and solve exactly that problem. That's what we are trying to do in Milestone.
One of the open source projects out of Granulate is called Gprofiler, and it looks really interesting to me. What was sort of the back history of Gprofiler?
So Gprofiler is a story that I personally like a lot. I mean, I'm a bit biased because I was the product manager who sort of took it from day one. It started out as an internal project because obviously as an optimization company, we are sort of obliged to have all of our services running at top performance and not have any excess waste. So we had an internal tool called Profiler, which was running across all of our services and helped us do anything from profiling our internal services to performing. We're basically a research company. So we have a research team which does long-term researches to try to find additional optimizations to our core offering. And that Profiler was the go-to tool when doing any type of research. So we started internally. It was started out small and it started getting more and more traction. And we started building this internal profiler, which was comparing it to, other profilers out of the market was something quite impressive. I mean, we used many different types of profilers from Perf, which is the native kernel profiler, to profilers in Java, profilers in Go, profilers in all of the different languages. Some of them we took open source projects and we basically improved them. And in some cases, like in the Python example, we actually built a profiler from scratch based on eBPF. And we've packed it into one agent that runs with very low overhead and allows to profile many different types of application, whether it's Kubernetes specific application, big data application, VMs application, and aggregated cluster wide. So I think one of the most impressive stuff around the profiler is the fact that we are able to aggregate data, stitch it together from many different sources. So let's say you run a Kubernetes environment that's ephemeral and is spread across many different nodes. We are able to aggregate those information and create one unified view that shows you cluster-wide what's actually happening from the kernel side and from the applicative side. So basically build that one high-level view. And as that project, that internal profiler gained traction, we thought this could be something that would be very, very valuable to the community. And we wanted to really give back, and we decided to, first of all, give it out as a free tool for any dev team to be able to use, and open source it mainstream to allow any developer to basically help us in the effort in making this widespread and helping any team be able to pick up a profiler with no heavy lifting and make it easy to profile and see the results, optimize performance, and maybe translate it even into cost reduction.
So when you started talking right then, you spoke about excess waste. How much waste is too much waste?
I will refer to my previous answer. I say it really does depend on a specific application. I mean, some cases, 20% is a lot of waste. Sometimes 20% is no waste. It really depends on what your needs are. I think people always have a tendency to think they have less than they actually have. I mean, there's always room to squeeze in more. Like you can optimize always more. It's a never-ending process. So I think I don't have a one quick answer for what's access waste.
Well, it's conditional, like you said. But even if you had waste today and someone put in a new version of their app, that waste has now given you the spare capacity to actually run that app for now. How should we be tracking those kinds of things? It's like, okay, our normal state is this. We've been running for this long. This is happy state. And then all of a sudden, a new version comes out, and we're now running out of bounds from that. How should we as application developers think about that? Because, again, I've written my application, I've made a change, and now where I've been running fine for the past 3 years has now completely changed. And it's because I had to write this new feature in that business required that has now, as it's flowed downstream into the runtime, is now causing problems.
So I'll address it from two different perspectives. So one, regarding having that spare capacity for the rainy day, I think it's crucial to have some access capacity in any given time for that rainy day, for that Black Friday where you get a lot of visitors into your website, having that specific with like companies that work in the sports industry, for example. You have a big game and you have a lot of traffic coming in. You have to have that access capacity. But other than that, and now in like the current reality, if you properly tune your environment using the elasticity of the cloud, using those internal mechanisms such as auto-scaling, using HPA properly, you should be able to have very little, like a thin layer of access capacity, and not be in a place where you're using very low utilization of the nodes you provision. So I think that we're in a place where you don't need a lot of access capacity. It's not like back in the days where you have that procurement process and you buy just in case of that rainy day comes in. You, first of all, you can prep ahead of time and try to look at historical data and see what is that access capacity you've been dealing with based on previous events. And properly tune your environment, I would say that's one of the most important things to not get to that wasteful state. So that's one angle of it. And regarding what you said before, I think that's something I can totally relate to. I mean, we've seen it a lot where people have hit that sweet spot, have spent a lot of time, resource, a lot of energy trying to get to that sweet spot. And now something has changed. You roll out a new application, you just changed something in your infrastructure, you went from monoliths to microservices, you moved cloud. I mean, so many things are changing nowadays, and that happens all the time. And I think my take on it is basically try to monitor any one of the different changes and see how that impacts performance. So I would say make sure that you have the right observability tools, such as having the right APM solution and have the profiler and be able to look at the change and isolate how that impacted performance, how that impacted cost, how that impacted availability. And if you do that again and again, you are able to basically see how every small change has impacted one of those 3 areas and be able to react properly. So if it's a performance issue, then maybe you can roll back and consider another solution. We've seen many cases. I mean, we also have an internal case study around it, how we rolled out a specific application that was using a specific function that was very inefficient. And we were able to view it once we rolled it out on the profiler. So we rolled out a specific version. We looked at the difference between how it looked before and after that specific rollout. And we saw how just a single function impacted performance in a way which was very impactful for the performance, also from a cost perspective. And we just rolled it back. We rewrote the code in a way that was more efficient. And then we rolled it out again. So basically just monitoring and keeping an eye out for every different change and how that impacts all of the different moving parts.
We're used to hearing about APM, but not that combination of APM plus a profiler. I mean, I think back the decades ago that I've been doing this, profiling was extremely hard. And you tried to not do it because it was extremely resource intensive and just trying to aggregate the stuff. I mean, now we got flame graphs and we can do all the cool things. And this is something I haven't really thought about, is by marrying those two things together, because the APM data is only a certain amount of, it's only a small piece of the pie of the real metrics that we need to understand. By taking those reported out metrics and comparing them against the real profiled metrics, have you ever seen those go sideways of each other? That's an interesting way to look at it. Let's say the APM is reporting everything's good, but the profiler is saying, what is going on?
Yeah, I mean, that could happen. But the real question is, what is the problem? I mean, that's also something that we need to address, I think, because you can start, I think there are two approaches into deep diving into a profiler, looking to the flame graph and try to investigate it. One would be, I'm looking at my matrix, I'm looking at my traces, I see something is wrong. I mean, I have P95, latency is spiking, I have a container that keeps on restarting, I have an actual production issue I want to address. And usually, in most of the cases, the problem would be the code issue. So people use the combination of using an APM and a profiler to isolate a specific area they need to focus in, and use a profiler as the way to deep dive and understand what's the actual code that's making the issue. I mean, in many cases, just a specific code indication. It could be an IO issue. It usually traces back to a specific function within the application. So profiler would be a great way to investigate it. So that's one approach. And the second approach is sort of an opportunistic approach, because going back to that sentence I said before, you can always optimize more. I mean, I think there's no glass ceiling into optimizing. So we have many of our customers who don't use the profiler as the way to solve performance issues, but go for that opportunistic approach where they use it periodically. They go back to the profiler every 2 weeks, every month, every quarter. It depends on the company. But they use the profiler as a way to find things that can run better, that can be more optimal, that can be less wasteful. I mean, it depends how you look at it. So going back to your question before, there are many cases where you look at your matrix, you look at your traces, and you say, okay, everything is fine. I have nothing to worry about. But then looking at the profiler, you could see that something is suboptimal. There's a specific part of your code that's not efficient. And if you'd optimize it, you can do the same stuff you've done in the past with 100 servers. Now you can do it with 20, but just changing up some part of your code that doesn't impact the logic. So I think that's the use case we've came across quite a lot, actually.
So we've talked about gProfiler, which is an open source project. We've talked about gMaestro, which is specifically for Kubernetes. Granulate has one other product that's called gCenter. What's that about?
There are many names to our core product. Some people refer to it as gCenter. Some people call it real-time continuous optimization. So our core offering is basically, it's an agent-based solution, which learns specific application resource patterns and data flow within your specific application, and basically rewires the internal workings to make it more performant, and basically translates those performance improvements into less cost at the end of the month. So it's a 3-step process. You install an agent, which learns specific patterns. Then we build a configuration for that agent and deploy it on each one of the different services you want to optimize. And then basically it's an autonomous solution. So basically the agent sits on the machine. It does its optimization on each of the different machines based on the stuff we've learned during the learning phase. And that translated into, the second you activate the agent, you would see a reduction in CPU utilization, an increase in throughput, a reduction in latency. And then taking those performance improvements, you can reduce the amount of servers needed while keeping the same SLA you had before, and even better. So basically you can reduce the cluster size by 30, 40, 50, even 60% sometimes, while having the same performance metrics you had before.
So walk me through a case of, I've got the agent installed. What's it doing to my machine?
So let me take a step back. So if you look at it from a kernel's perspective, so the kernel, specifically Linux, was built as a general purpose machine, basically to address many different use cases. And the main use case would be a user behind a keyboard who's doing many different things in parallel. From the resource allocation point of view, the kernel, the CPU, is allocating resource to each one of the different processes in the same amount, in a fair way, in order to keep the user at the end of the keyboard in a way that makes the application look interactive. So It allocates resources equally between each one of the different processes. Now, if you look at the way that production workloads are designed, specifically compute workloads, they have a single purpose. Each one of the different services has to do one thing, and it has to do it properly. So what we do is we learn the specific resource usage patterns of a specific application, and then we change the resource allocation that's done by the CPU to be tailored to your specific needs. So we would rewire the way that the internal queues are built in order to best serve the needs of your specific application.
So you're going in and making system level changes to Linux kernel tuning.
We have a runtime module that sits on top of the CPU. We tap into the internal mechanism of the resource allocation, and we basically make them application specific. We make sure that each one of the different processes, each one of the different threads get the optimal amount of resources. So that would be mutexes, that would be the right amount of CPU, right amount of memory, and make it optimal for your application. And the impact is immediate. I mean, that's the fun part. It's an autonomous solution. Doesn't require anything from your end. You just install the agent. It learns specific patterns, builds the configuration based on what it learned, and once activated, basically starts optimizing it, and you would see an increase in performance right away the second you activate it.
What's that average learn time? Or what do you recommend from a learning perspective?
So it usually lasts from a week to 2 weeks. That would be the average. It does depend on the type of applications. So we have cases where learning phase would be quicker. Some cases it's a little bit longer, but it would vary from a week to 3 weeks, I would say.
Which would make sense because not all workloads are running all the time.
Exactly.
Think about a general retail e-commerce store that's going to follow some sort of sine wave pattern so you probably want to run that one at least a week. That way you've got a full week cycle of what's going on. Hopefully you didn't run it during your Black Friday specials because that's not normal life, right? So I would assume also that you would want to try to tune it at normal times, or once I've activated this now new profile, is it sort of like what we were talking about earlier with profiling? Do I just go back and run it every month or every quarter or whatever to retune? Or is this something that's sort of automatic of, okay, here's the profile that we've applied, and then all of a sudden I get a notification about 3 weeks later saying, hey, we've seen changes, we've got a new profile for you whenever you're ready. What does that look like?
So basically we have the agent running on the machine, continuously learns the changes and reconfigures properly based on the new changes. But I would connect it to the profiling discussion before, because basically the way that we do the learning, like the first phase of the learning is that we take the profiling data, we ingest it, we look at that as a prerequisite, and we can understand how much potential value we have on that specific cluster. We start from there, and once the agent is installed, it also installs the profiler and uses the data from the profiler that was installed to make sure that the learning is still relevant, make sure the configuration is basically optimal for your specific application, and retune it until we get to that swap.
So Granulate is at granulate.io. Yes, I had to go back and double check it. Granulate.io. So if you want to check out Granulate, you can check that out. Also, if you want to check out, we talked about the project gprofiler. That is also can be found at granulate.io, but it also has its own site, gprofiler.io. Noam, if anybody wanted to get in touch with you, what's the best way to do that?
You can first of all subscribe. We have a Slack channel for the community. It's both for MyStore, gprofiler, also for gcenter, or anything cost or performance related. So I think that would be a good way to start. You can reach out directly. My email is noam.salinger@granulate.io. So if you have any question, anything you want to discuss, DevOps, FinOps, whatever, I'm more than open to it. And I would say also a small note that both our products, both gMyStore and gprofiler, currently have a free version. So I would say go ahead and try it out and let me know what you think.
So we'll have all of that information down in the show notes. Noam, thanks for being with us today.
Thank you very much. I had a lot of fun with you guys.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at DevOpsParadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.